Okay, hello. I guess this is Purpix. Leetcode 458 Purpix. This is a hard question. Yeah, I think you can read the question out by yourself, and let me get straight to the explanation. So how is this going to work? Yeah, so you're given a minutes to test, let's call it T, big T. Also minutes to die, let's call it small t. Also number of bucket B, say capital B. And among this bucket, there's exactly one poisonous. And also you're given, you can say that you have infinite amount of pick and you have to choose minimum number of pick. Let's say you pick 3 random picks, the first one, second one, third one, and you have to fit this pick, the bucket, so that you can find which one is the poisonous one. Fit the first one, then you fit this second bucket to the second guy, and the third one to the third guy. And if any of them, oh hold on, and then you have to wait for t minutes, and during these t minutes you can only observe them, and you cannot fit any other pick during this time. So you can only observe them, see which one they died, which of them died, and so you can confirm which one is the poisonous one. If any of them don't die at all, then you have to conduct another test. So you fit another bucket to your picks. Then you do this until you find the poisonous one. But you got minutes to test, you get limited time. Let's say minute time is 30, and minutes to die is 15. That means you can only conduct 2 tests. So with 2 tests and also number of bucket, you have to find the minimum number of picks needed so that you can check each bucket and also find which one is the poisonous one. And that's the main objective of this code, this question. Also, one thing that I think is the most crucial part in this question is that you actually can fit a single pick in a single test. You can actually fit multiple bucket, and yeah, that's one thing you have to know. Okay, so what's the solution for this one? Well, I think this is going to be a bit confusing, so I want you just to follow me along for a moment. So the first thing I would like to find is the number of tests I can perform. Let's take the test cases from Leetcode. 60 minutes to test and 15 minutes to die. So how many tests I can perform out of this number? It's basically 60 divided by 15. I got 4 number of tests. Then let's say I got 1 pick in here. I got 1 pick and 4 tests. What I would like to find, the next thing, is the number of bucket I can take, whether it's poisonous or not, out of this 1 pick and 4 tests. So the number of tests should be 5. Why 5? Let's say we got 5 bucket in here, and I got 1 pick in here. First of all, I fit this pick, the first bucket, it takes 50 minutes and it doesn't die. I take the second bucket, it doesn't die as well after 50 minutes. Then the third bucket, after 50 minutes, it doesn't die. Then the fourth bucket, 50 minutes, it doesn't die as well. We have tested 4 times, and it led us to 60. As we can see, it is the number of tests, the limited number of tests, number minutes to test, and we still got 1 last bucket in here, and we haven't checked this one is poisonous or not. But since we have checked the first 4, and the pig hasn't died yet, so we can conclude that the last one is the poisonous one. The first 4 is not the poisonous one because it doesn't kill the pig. Why is the last one is the poisonous one? Yeah, because the question stated that there's exactly 1 poisonous one in the bucket. So that's for 1 pig. But what if there is 2 pig? How many number of bucket we can take out of 2 pigs and 2 tests? 4 tests, yeah. Well, the answer is 25. Why 25? Let's say, oh no, I think I have to. Let's say I'm gonna arrange this bucket in the matrix thing. Use this one for a moment. So I've arranged this bucket, 25 bucket, in the matrix form, and let's say I got the first pick in here and the second pick in here. And I'm going to take the first row. What I'm going to do is to take the first row and fit this group of bucket to this first pick, and just take the first column, yeah, and fit it to the second pick. If any of the pick doesn't die, that means the poison is not in the first row and not in the first column. Then I take the second row and the second column. I fit this one to this first pick and this one to the second pick. If the pig hasn't died yet, that means the poison is not in the second row and not in the second column as well. I keep doing this until I run out of tests, number of tests, and so I can only do 4 times of 4 tests. Now we left with this last bucket in here. If the pig still doesn't die yet, that means the poison one would be this one, because we haven't checked this one, but we have checked the other one. Now using this method, we can suddenly check 25. If you're still a bit unclear why this works, let's say the poison is in the here. So what would happen? The first pig would die after taking the third row of bucket. After the third test, the first pig would die. So we can write 3 in here, and the second pig would die after the second test. So which bucket that is in the second row, not the second row, in the third row and the second column, which is this one. So we can confirm that this is the poison one. Let's say, take another example, is the poison is in the here. So what will happen? Well, the first pig would die in the first test. We can say this 1, and the second pig wouldn't die because after taking 4 tests, the first 4 column, it doesn't die yet. So we can say that the poison one is not in the first 4 column. So the poison one should be in the last column. You can say 5. Know which bucket that is in the first row and also is in the 5th column, which is this one. So we can confirm this one is the poison one. Well, using this approach, we can find 25 up to 25 bucket for 2 pigs. So with 2 pigs and 4 tests, we can take up to 25 bucket. Well, the one before was for 2 pigs. What if there is actually 3 pigs and 4 tests? How many number of bucket can we test? Can we check? Well, the first one would be, if there's 1 pig, there would be a linear, the 1D, we can say that way. And if there's 2 pigs, there we would want to make a 2D matrix. And if there's 3 pigs, then we would like to make a 3D matrix like this. So the answer will be, this one will be n, this will be n square, and this will be n cubic. And the answer will be 125. What about 4? No, 4 pigs. It would be 625. And what about 5 pig? It would be 3125. And yeah, I think it's going to be better if we can find the formula for this one. So the formula would be, let's say the number of tests is n plus 1, because we can take the extra 1 bucket out of the 4 test case for number of tests, and we're going to power of it, n plus 1 to the power of number of pig would be number of pig. Let's say the number of tests is 4, and plus 1 will equals to 5. To the power of first, it will equals to 5. Yep, we got this. What if the number of pig is 2? Then we got 25. Number of pig is 3. We got 125. Number of pig is 4. We got 625, and so on and so on. So we got the formula. It's n plus 1 to the power of p. But not yet. We still need to do something else, which is, since the Leetcode asked us to, already given us the number of bucket that needed to check. So this number should be bigger or equals to the number of bucket. Let's say the bucket is b. And this is the formula for our code. We're going to work with this formula for our code. Now let's use the Leetcode test case, the first test case, which is 1000 bucket. So we still got the same number of tests, which is 60, and number to die is 15. We got number of tests is 4, the same as before, and we need to check 1000 bucket. The question is to find the minimum number of pig needed to check all of the 1000 bucket, which one is the poisonous one. So it would be bucket n plus 1 to the power of p has to be bigger than or equals, has to be greater than or equals than b. So we have to find the exact number of pig that if we n to the plus 1 to the power of pig, number of pig, it will be equals or bigger than 1,000. So which one is the right answer? It will be, I'm gonna put 4 in here. 4 plus 1, this is to the power of p, has to greater or equals to 1,000. So we have to find 5 to the power of p that would result in bigger or greater or equals than 1,000. The answer, let's say what if the first pig only 5, it wouldn't exceed the 1,000 bucket. The second, what if the p is 2, then it would return 25. It hasn't greater or equals than 1,000 yet. Or about 325. Keep going on till we find the right answer, which is the 325, which is the p is 5. So 5 to the power of 5 is greater or equals than 1,000. So the answer would be 5, this 5. Number of minimum number of pig needed is 5, so we can put the answer to 5. Now we got, I think it's a bit clear now. So we're going to jump to the code. So we're in Leetcode now. So how are we going to do this? First of all, we're gonna make a variable. The count equals to 0. The count is to calculate to get the number of pig. Then let's call it b test. B test would be number of bucket I could test with number of pig and a number of tests I could do. It should be 1 because I'm going to multiply this, and if it's 0, then we would just keep multiplying 0. Then while b test is less than buckets, number of buckets, then I would like to first of all increment the count. Then I'm going to multiply b test by the number of tests, which is minutes to test. Oh, come on. Test divided by minutes to die. I have to put it inside the brackets and have to plus 1. Then I think that's all I have to do, and I'm just going to return the count. Yeah. And it takes, there we go, it is work. Yeah, pretty much like this. And so yeah, if you find this helpful, okay then, okay, sure. Yeah, if you have, yeah, whatever, if you got anything to ask, you can ask in the comment, and yeah, I'll try to answer it, probably.